Hi, today we will be solving Leetcode question 121, best time to sell and buy stocks. You are given an array prices where prices of I represents the price of each stock on that particular day. You want to maximize the profit by choosing a single day to buy one stock and choosing a different day in future to sell the stock. Let's try to understand this question. Let's take this example to understand the question. So on day 1, the stock price is 8. On day 2, it's 2. On day 3, it's 6. On day 4, it's 1. On day 5, 7, and so on. So when you look at a question, the first approach you should think is the brute force approach. So what could be the brute force approach? That we are sitting on day 0, and then we look in the future for every other day, and we try to find out the maximum profit that we can achieve by buying on day 0 and selling it on day anything in the future. So 8 minus 2, so we are buying the stock at 8 rupees and we are selling it at 2 rupees. That's a loss, so we won't do that. On selling it for 6 rupees, loss, 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 loss. So this is not a good deal. Let's try to buy it on day 2. On day 2, we are buying the stock at 2 rupees and we are selling it for 6 rupees. That's a profit of 4 rupees. Then we'll continue. On day 3, we are selling it for 1 rupees. That's a loss, so we are not going to do that. On day 4, we are selling it for 7 rupees. That's a profit of 5 rupees. So this is our new maximum profit. On day 6, we are selling it for 5 rupees. That's lesser than what we could have done, so we are not going to update our maximum. And then on the last day for 1 rupees, which is a loss, so we are not going to do that. On day 2, we'll buy it for 6 rupees. Selling it for 1 rupees will give us a loss, so our current max for now is 5. So this is buying for 6 and selling for 1 is a loss. Buying for 6 and selling for 7 is a profit of 1 rupee, so that is less than the maximum profit that we could have got. So we are going to ignore this. In this case, we'll make a loss, and here also we are going to make a loss. We'll continue to iterate. On day 3, we will be buying the stock for 1 rupee, and on day 4, we can sell it for 7 rupees. That's a profit of 6 rupees. So our new maximum is 6 rupees of profit. Let's continue. Buying it for 1 and selling it for 5, a profit of 4 rupees. So we are going to ignore that. And buying it for 1 and selling it for 1 again is no profit, so we are going to ignore that as well. On day 4, we are buying it for 7 rupees, selling it for 5 rupees, loss. Same thing, 1 rupee loss. On day 5, buying it for 5 rupees, on the next day selling it for 1 rupee is a loss, so we are going to pass that. On the last day, there's no other day to sell it in the future, so we are going to pass that. So this is the brute force approach. Let's try and code this approach. So what we will be doing is, we will keep a counter, keep a maximum profit variable which will store the maximum profit as we go past in each approach. We'll initialize it to 0, and then we will start 2 loops in 2 for loops. The one starting from the one starting from 0 all the way till size minus 1, and the second one starting from the one immediately next to the buying day and going up till the last day. So this should go from day 0 to day n minus 1. So the intent of doing I plus 1 is on the day we are buying it, we will try to sell it from the very next day, and we will try to see which is the best day possible to sell it. So this works. Let's try and submit it. As you can see, this is a valid solution. It has cleared almost 200 test cases out of 211. The only problem here is that the time limit has exceeded. Let's try and understand what's the problem in this case. So in this approach, what we are trying to do is we are starting from an individual day, and then we are traversing every single day after that. And this happens continuously till we reach the end. So what effectively is happening is this is a big O of n square solution. And big O of n square does not matter when the input size is small, but when the input size becomes a magnitude of thousands, it becomes the time becomes a magnitude of millions. So we should try to optimize this approach. Let's try to do the optimized approach. So we could try to do this in big O of n time complexity. What we could do is we could make a temporary array, and we could record the maximum prices of the day after it. So we will start from here, and we will try to store the maximum price of the stock from the last day going till the first day. So the maximum price of the stock on the last day, starting from the last day, is 1. Now this maximum price is 5. Now the maximum price is 7. Here the price is 1, but the maximum price is already 7. So if we have bought the stock in the past for 2 rupees, there is a possibility in the future that we can sell it for 7 rupees. So the max price is 7 rupees. So we are not going to update the max price. It will be 7. 6 is less than the max price, so we won't update it. 2 less than the max price, so we won't update it all the way up till 8. In this case, the max price will be 8. So now we will try and find the difference between the buying price and selling price. 0, 0, 0. Oh, the difference is 6. This is our max. Max profit is 6 till now. Max profit is 1. No, sorry. The profit is 1. Profit is 5 in this case. The profit is 0 in this case. So we have found our solution that max profit will be 6. So this is our solution. Let's try and code this solution. let's keep a variable for keeping the max profit. So we'll track it. We should keep a day. We should keep a max max price of the stock day as well. We'll initialize this to 0. Let's store the size of the array in a variable so that our lives become easier. Let's initialize a temporary vector or an array. Let's initialize all the elements of this array to 0. Let's iterate from n-1 all the way up till 0 and find the maximum price of the stock for the days beyond it. So in the temporary array, we will keep storing the max price of the stock as we go along, and this will only happen if the stock price is greater than the stock price we have encountered till now. Now let us try to find the difference of the stocks, and that difference will be our profit, and we'll return that profit. So maximum profit will be updated once we encounter a profit which is greater than the profit we have currently seen. So once we have iterated through this loop, we'll be getting the maximum profit and we'll return it. So we have completed it. Let's try and submit this. So this solution is completely valid. We have completed this solution without any errors. Let's try to understand its time complexity. So what we are doing is, for making this array, we are traversing the original array once. So the time complexity becomes big O of n. If there are 10 elements, we'll traverse it. We'll have to traverse through the array 10, all the 10 elements. If there are more elements in the array, we'll have to traverse it through the entire array once. So the time complexity is big O of n, and for making the profit, we'll have to traverse the array once again. So the time complexity for that is also big O of n. So we can say that this belongs to time complexity big O of n. But can we optimize it still further? Could we do it that the time complexity is O of n and the auxiliary complexity is O of 1? Because in this case we are using an auxiliary complexity of O of n. Let's try to optimize it even further. What we could do is, in this case, we are trying to find the profit, maximum profit. So we will start from the first day. We'll have 2 pointers. One will be the left pointer and one will be the right pointer. So the left pointer will point at the day when we are trying to buy the stock. So initially the left pointer and the right pointer will be on day 0. We will keep moving the right pointer. So on day 0 the price is 8. On day 1 the price is 1. What we will do is the price is 2. What we will do is, as soon as we find a day on which the profit is lesser than the profit of the previous maximum, we will shift the left pointer to this new right pointer. So the left pointer belongs here. And we will continue to move the right pointer. So the max profit is 2 minus 6, that is 4. So the max profit currently is 4. Let's try to move the right pointer again. Now we see that on day 3 the price is 1. So let's move the left pointer to this current right pointer and keep moving forward. Here we see that the price is 7 and the max is now 1 minus 7, that is 6. Now let's keep moving forward. The price here is 5, so the profit is 4, so we need not to update it. Let's try and code this solution. Let's keep a variable to keep the maximum profit. Let's initialize it to 0. Let's keep a variable to store the size of the array so that our lives become easier. Let's keep 2 pointers, both at 0 initially, a left pointer and a right pointer. Let's keep 2 pointers, a left and right. Let's check if the prices of the right pointer is greater than the price of the left pointer. Then we would try to find the max profit. And if it is more than the current max profit we have, we'll update the max profit. If that is not the case, if the right pointer's price is not higher than the left pointer's price, we will just move the left pointer to the position of the right pointer. And in each case we would want the right pointer to go ahead. Let's try and submit the solution. So this is a valid solution. Let's try to find out its time complexity. So what we are doing is we are traversing the array exactly once. So the time complexity would be O of n. And we are not using any different arrays, we are just using 2 or 3 pointers. So the space complexity is O of 1. I hope you learned from this tutorial. If you did like this tutorial, do like and subscribe and do share it with your friends.